Rolle's theorem. All right, first I want to show you kind of graphically what's happening with this theorem. So if you have a function, so here's f of x, and it is curving a couple places, so clearly that's an x cubed function, right? And you've got an interval, so if you look up here, so here's your a value, here's your b value, right up there, not here. And what Rolle's theorem says that if you have this closed interval, these solid dots right here, and the function is continuous, meaning there are not any breaks or gaps or asymptotes or anything like that. And if you can differentiate it between a and b, and one more condition, if you have the closed interval, these endpoints, a and b, if f of a, if the heights equal each other, f of a is equal to f of b, what it says is there's going to be some point, it doesn't have to be directly in the middle, it could be here, could be here, but there's going to be some point where we're going to call it C right here. If you look up there at C, there's a tangent line that's horizontal. So that's what this says right here. So if you've got a function that is continuous and differentiable, oh my gosh, I can't speak, between a, b, and if at some point f of a is equal to f of b, then there will exist a c value between a and b, so somewhere between here, that f of c, when you plug c into this f of x right here, so f of c, it's at its height, the tangent line is going to be horizontal. So let's look at what the actual theorem says. So in math terms, it says, that looks like that's a prime. That was just a parenthesis, sorry. F of x must be continuous on the closed interval AB, meaning those are solid dots, and differentiable on the open interval, meaning that would be, you wouldn't include A and B on the parts that's differentiable. And if you plug in A into the function, it should equal when you plug b into the function. So f of a should equal f of b. There's going to exist a c value on this interval. So somewhere in between a and b, there's going to be a value such that when you plug that value into the function of the derivative, you find the derivative, you plug c into it. And because remember, the derivative produces a function that gives you the slope of the tangent line. So when the slope of the tangent line is 0, that confirms Rolle's theorem. So let's go ahead and try one real quick. So for each problem, find the values of c that satisfies Rolle's theorem. So you have to determine if it's continuous on the closed interval. So here's the interval right here, and differentiable on the open interval. So here's a tip. If the function is a polynomial, think about all of our parent graphs that we have at my board in the front of the room. Polynomials are continuous and differentiable, right? So it is going to be continuous on the closed interval, and it is going to be differentiable on the open interval. All right, so the second one says, does f of a equal f of b? Well, let's try it. So here's your a, here's your b. So f of 0, so we're going to plug 0 into each one of those. Well, negative 0 squared is 0, so that's going to be 0. 4 times 0 is 0. So when you plug 0 into there, you're going to get 1. Now we're going to plug in b, f of 2. So 2 squared is 4. 4 times negative 2, that's going to be negative 8. Well, plus 4 times 2 is 8. Those two cancel each other out, leaving also plus 1. So guess what? F of A does equal F of B. So those two things are marked off. Now what we have to do is find the derivative. When we find the derivative, we have to see if there's a point in between that interval where the tangent line is going to be 0. So let's go ahead and see what we did here. So when we find the derivative, there's y is equal. So dy dx, you end up with negative 4x plus 4. Well, we're going to let this side equal 0. Remember, we want the slope of the tangent line to equal 0. So we set the other side equal to 0. And then notice right here, we're going to factor out a negative 4, leaving x subtract 1. And right away, we can see x is going to equal positive 1. And look at that. 1 fits snugly right between 0 and 2. So yes, it meets the criteria. That's it. That's what you're doing on Rolle's theorem.